Right, welcome to the third module. Today we're going to revisit some basics. I will show you how to perform some basic operations that you already know in a more efficient manner. Afterwards, I will introduce the basic building blocks of programming, like iteration, conditionals, or functions. And this knowledge is very general. It will be helpful for most programming languages that you will encounter, for example, MATLAB or R or Java, you name it. Afterwards, I will show you how to join different data sets and how to merge them together. We will look at how to manipulate text or data that comes in a text format. And finally, we'll take a quick look at web scraping. All right, so first, let's look at the pipe operator that we introduced in the last module. And if you remember, the pipe operator basically allows us to just use the output from one function or one operation as an input into the next operation. And it therefore allows us to write several steps of the process in one line and therefore write much more concise code. However, we always still have to write kind of what we would like to have as an input in our initial data set, right? Now to write this even more concise, we can use another operator, which is called the assignment pipe. And the assignment pipe is essentially written the pipe, but you have these two less and greater than symbols, creating these like arrows that point in this direction, in both directions. And what this pipe does is it essentially allows you to take the output from one operation as an input for the next function, and afterwards feed the output from the second step back into the first step. So for example, if we would use the data frame as an input for the rename function, we rename the variable, and if we use the assignment pipe, we would automatically replace the renamed variables in the original data set. So what this saves us is writing the data frame that we use as an input basically on both sides of this assignment symbol, since the assignment pipe automatically assigns the output back to the original data set. Another very useful data type are lists. And lists are fundamentally very different from arrays. So they also store different units of data together in one data type, in one variable. However, since they're not really data frames or vectors, but rather you can think of them as kind of linked objects, they're able to store very different data types and very complex objects all in one container. So if you want to create a list, you just use the function list, and inside you just list all the elements that you would like to have combined in one list. So for example, here we have a data frame called wages, a data frame called date, and we have a description. You can see that wages df is a data frame. So is the date data frame, but we can see that they're very different data frames. So the wages data set contains a lot of different variables of different data types. The date is smaller, and then the description is just one string. So it's an entirely different data type again. However, the list allows us to combine these three very different data elements into one object. And the way it does that is it basically links them together. And if you look at it, we can see that we now have created my list. My list contains as a first element the first data set, as a second element the second data set, and as a third element just this one string who serves as a description. If we would like to access one of those elements, we do this by using the double square brackets. And what this does is it just it just extracts the third element from the list. In this case, this will be the character with this description. In the migrator package, we get a function called extract or extract2, and it basically does the same as using the double square brackets. It just gives us back the first element from the list, and which in this case would be the wages data set. We can also extract elements by their name if we have named the different elements of the list. Very often, you have a list that contains, that is essentially an atomic vector. It's just a list instead of a vector. So for example, let's say you have a list that just contains for each person the wage, in which case we could as well store this in a vector. And if we want to turn a list that contains atomic elements into a vector, we can use the Unlist function. And here we have this simple list, which just has 4 elements, and each of these elements is just one integer. We pipe it into Unlist, and what this does is it just turns this simple list into a numeric vector with 4 elements. And here you can see an application of this assignment pipe. So what this does essentially is that it pipes the simple list into Unlist and reassigns the value, the unlisted object back to a simple list. By using the additional pipe here, we then use this unlisted element into the structure function so we can take a look at it.